Dear students, in continuation to the various speed control method of induction motor drive, now the next method is the slip power recovery method. The diagram shows an equivalent circuit of wound rotor motor with a voltage VR injected in its rotor. In this method, we inject the additional power using a voltage, so using a source which is denoted by VR here. This is an equivalent circuit of the induction motor drive RS, XS, E. It is the stator side resistance and it is the rotor SXR, RR. And instead of shorted this rotor side, we have inserted voltage here, voltage source here. So when rotor copper loss is neglected, the mechanical power PM equal to the PG minus PR. PG, where PR is the power absorbed. If this is the source of to absorb the power, when PR is the power absorbed by source, and VR is the magnitude and sign of sign by source VR. The magnitude and sign of the VR can be controlled by controlling the magnitude and phase of VR. By controlling the magnitude and phase of VR, we can control this value PM when PR is 0. Suppose the PR is 0, then PM equal to the PG means motor is run its natural speed, and a positive PR, a positive value of PR will reduce the mechanical power, which in turn reduce the motor speed. Similarly, when PR is made equal to PG, then PM and consequently speed will 0. When PM PG PR equal to the PG, then PM equal to 0, it means the speed will equal to 0. The variation of PR from 0 to PG will allow speed control from synchronous speed to the 0 speed. So when polarity of VR for this operation is shown by the continuous line, and if as in this circuit there are two lines as a continuous line and a dotted line. Dotted line shows the uh, operation PM equal to the PG minus PR, and dotted line show equal to the PG plus PR. Means we can control the speed above the synchronous speed using the PR. So when PR is negative, is then VR at a source of power, PM will be longer than PG, and motor will run at a higher speed than synchronous speed. So polarity of VR for speed control above synchronous speed is shown by dotted line. When rotor copper losses is neglected, PR is equal to the slip power SPG. This PR can be in turn written as the SPG if the this power can be shown as SPG. S is the slip. So by controlling the PR, we can control the SPG. We can show it as SPG. So this is called the slip power. When SPG, speed control below synchronous speed, is obtained by controlling the slip power, the same approach was adopted in the rotation. The main difference between the rotation control and this method, in this method, in the rotation control method, we wasted the power in the rotor circuit in the external resistance. Instead of that, in this method, we will use that power either given either absorbing by the source or given to the motor. So it is useful. Therefore, this method of speed control classified, and further this method are further categorized in two parts: slip power recovery scheme. This is slip power recovery scheme. One is the static scrubbers drive and one is the Kramer drive. So first method is the static scrubbers drive. This is the circuit of scrubbers drive. In this is a motor, this is the rotor circuit, and from the rotor circuit there is a rectifier which converts a portion of the power into the DC. This is the inductor, this is the DC current ID, and this DC current is converted, this DC power is converted again into the three-phase AC and fed back to the again to the source or main line. So this is the voltage VD1, this is the voltage VD2, and this is the transformer whose turn ratio is M ratio 1. So if motor provides the speed control for rotor below single speed, this speed method, this circuit has been used. A portion of rotor AC power is converted into the DC by diode bridge, as we have seen, and then control rectifier working as an inverter converts it back to the AC and feed it to the back to the AC source. So power feedback, the power which you have fed to the source, it is denoted as PR or SPG. So we can control the inverter counter EMF VD2. So this voltage which we have seen the VR is basically the VD2. So by controlling the VD2, we can, or in turn by controlling the power feedback to the source of PR or SPG, we can control the speed of the motor by controlling the PM. So uh, how we can control this counter EMF, which in turn is controlled by the controlling the inverter firing envelope, and the DC link inductor is provided to reduce the ripple in the DC link current ID. So DC link inductor basically reduce the ripples and separate the AC circuit to the DC circuit. Since slip power is fed back to the source, unlike rotational control, it is vested resistor, high efficiency. Drive input power is the difference. Drive input power is the difference between motor input power and power feedback. If we can analyze this voltage VD1 and VD2, VD1 is given by root 3 6 upon pi. It is a fundamental value, root 3 6 upon pi as V upon N, and VD2 is the root 3 6 upon pi V upon M into cos alpha. Alpha is the firing angle of the rectifier circuit. Vm is the transformer turn ratio, and n is there is alpha is firing, and the stator turn ratio, stator to rotor turn ratio. So this is the, these values occur, this value are calculated by the fundamental value of this thing, and from this there is a circuit. In this, if we apply the KVL or loop, in this loop we can show that VD1 plus VD2 equal to the 0. So the VD1 plus VD2 equal to 0, we can put these value in this equation. VD1 plus VD2 equal to 0. If we put the value of from the equation 1 and 2 here, we get that the slip S equal to the minus n upon m into cos alpha, or a minus a into cos alpha, where alpha and the maximum value of alpha is restricted to the 165 degree for safe commutation of inverter thyristor. This is the limitation, that we can maximum value of alpha should be 165 degree. So at the lowest speed required from the drive, VD1 will have the maximum value. So VD1 maximum can be given as Vs max upon n. If we find the value of VD1, the maximum value of this expression is S into V max, V into S max divided by n. So this VD1 is depend on the value of maximum slip. S is coming only this expression, and this is dependent on S, and its maximum value is occur when S have the maximum value. So the VD1 maximum value of VD1 can be written as Vs max upon n, where S max is the value of slip at the lowest speed, and we have calculated the slip as equal to the minus a cos alpha, and if it is restricted, alpha is restricted to the 165 degree, so this expression can be written as Vm into cos 165 degree equal to the VD1 plus Vs max, it is VD2 plus Vs max upon n equal to the 0. So VD1 plus VD2, what is the expression? which is here, we can Vm upon cos alpha. Vd2 is the Vm upon cos alpha. Alpha can be put as a or if we put the value of Vd1 plus Vd2 in this equation, 3 root 6 upon pi is the common, and we can given in the 0 side. So this equation Vd1 plus Vd2 will become Svn upon n plus Vm upon into cos alpha. And if the maximum value of Vd1 is the, we put it is as a Vs x upon n, and the Vd2 is V upon m into cos 165 degree 165 equal to the 0. So the value of m can be written as 0.966. If we solve it, 0.966 s n upon s max. Such a choice of M ensure inverter operation at the highest firing angle and the lowest motor speed. So we can choose this such type of value, and we can further simplify the circuit which I have made here. We can put the SV upon N, SR dash, SX dash, XR, RR, and VR. VR is the rotor resistance. Refer to the rotor side. We have made this circuit refer to the rotor side. So equivalent circuit of the motor, neglecting the magnetizing branch. When refer to the DC link resistance, SR dash plus RR dash will be the equal to the 2 SR dash plus RR. If we further simplify this circuit, and then it will become SR dash or SX dash. So it will become 2. So this will become 2 SR dash plus RR dash plus DC link resistance RD. It is the VD1 and it is the VD2. So the DC link current we can also calculate here ID equal to the VD1 plus VD2 upon the total resistance. So this is all about uh, and this is a closed loop control circuit of here also. This is the we can take the feedback from speed feedback from the motor, and this speed signal can be given to the speed controller and generate the from the current limiter we generate the reference current signal, and by the summation of current id and id dash we can uh, through the current controller we can generate the firing angle, and which will get to the uh, SCRs of the inverter circuit. So such a scheme can be used as a closed loop control for discover drive. So it's all about discover drive circuit for this power recovery, and next method we will discuss in the next class. Thank you.